Welcome to Unlimited Ideas, your go-to destination of all things 3D printing and laser engraving. I'm Sam, and I'm today here to talk about heat breaks. As you know, we have different type of heat breaks. Some of them they have PTFE tube inside, and some of them they don't have. And some of them they are all metal. They are all metal, and some of them they are all metal but with two different materials. For example, copper and steel. What is different between them, and how we can improve our 3D printer? For example, in Elegoo Neptune 2S, and they are using this type of heat break, and they have a big hole at the middle. When we are pushing the PTFE tube inside, it's going through here, and it's next to the nozzle. For example, if we imagine this is the this is the nozzle for the Elegoo, and this is the PTFE. It's against that one inside the heat block, and filament is going through here to the nozzle, and then it's melting, and it's coming out from the nozzle. And because PTFE always it is next to the heat source here inside the heat block, it's going to burn out here, and then it's causing some issues. For example, you can find some filament in this shape or this shape when you are taking them out. Some of them, it's very hard to take the filament off, despite of heating up the heat block and get ready to take it out. It's not coming out because the head is bigger than the filament. It's not passing through the PTFE. So also you can heat up your block more than a certain temperature, because we are burning out the PTFE, and it's producing some kind of gas which is very dangerous. So we can use the biometal one, and or all metal one, bio one, or the all one type metal. Another things I need to mention it, when we are tying the nozzle here in the heat block and the heat break, when they are inside here, they are meet each other middle of the heat block, and when PTFE is inside, all the heat it's coming to the PTFE, and because of that is burning. So we can replace it very easily with the all metal one. This time I'm going to use the biometal, and we can test it after I change it in my 3D printer. For this type, this type, I'm going to tie the heat block to the heat block this much, because we can't tie it all the way inside. It doesn't have any stop to stop it. We can screw it to that surface, and then we can tie the nozzle against that one, and it's keeping these two together very well, and they are not going to ooze out. But for example, this type of Heatbreak, it has some kind of a stop here, and it's not going through all the way. It's stopping at the surface of the heat block here. It stay at the top, and the point is, and there are some other heat block which they have PTFE inside. Also, this kind of heat block they are going to damage inside of the heat block, and this type of heat block heat breaks. This type of heat breaks when we are pushing the PTFE, it's not going inside that much, maybe 1/4 of an inch or half a centimeter, or it's the same in bio or generally in all metal one. They are not going that much inside. They are at the top of the heat break, and until here, the heat sink, it can dissipate the heat. It's the same thing. And the point is we want to increase our temperature in the heat block for some certain material, and reduce this bulky head to this type of head. I take them out without heating up the heat block, and as you can see, we don't have that much here. It's when you are pulling, it's coming out very easily. Let me to bring the printer and get started for new heat break. Before opening the whole system, I suggest to heat up your nozzle because it's going to help us to loosen up the nozzle if something is stuck there, and we have some filament left over here, and they are stick to each other. With heating up, we can loosen that one, and we can open the nozzle first. And then we need to open the cover. And then we can loosen a little bit of the head here. Then we are able to open the take out the socks. And if we open the these screws here right now, it's going to be a little bit easier because everything is one part. Now you can turn off the heat to make it a little bit colder, then we can easier work on it and change it. So I'm going to replace it with the all metal biometal one, and for putting back inside here, as you know, head and Heatbreak, they are sitting on top of each other when they are and tied up inside the block. And so we need to put them some way. When we are tie them up, both of them, they are contacting, and nothing gap we have between these. It happened to us sometimes. Filament is bleeding out because we have some distance between them. Now for this one, I'm going to put the nozzle not all the way, a little bit outside. When I'm closing, it's going to push on Heatbreak. As you can see, I can't open it anymore because it has some pressure on the nozzle. That is good enough. when we have a little bit gap here, if I can show you in the video. We have a teeny tiny gap here. Now for closing the plugs, we can put them together until it's a little bit cold and we can handle it. Then again we are going to heat it up and tie them properly. We need to put the socks at the end of the It's almost tight enough for tying the screws, and then we can put the socks back on and close everything. This time I'm going to heat up the extruder up to 200 degrees and then tie the screws. Now my extruder is to 200 degrees. I'm going to tie these screws here and there. Now I can put back in the socks. And tie the screws to the Heatbreak. Also right now I'm going to tie back in the nozzle. Then can put back in the cover. Then we can put back in the PTFE tube. As you can see from this part, PTFE is going to stand up because it's not going down and there. And securing the PTFE. Then because we open and close the nozzle, I suggest you to re-level your bed and do a test print. As we wrap up this 3D printing and laser engraving adventure, I hope you have gained some valuable insight and inspiration. Remember, the sky's the limit when it comes to your creativity. And once again, this video is not a sponsor. If you enjoyed today's video, don't forget to subscribe, like and drop your thoughts in the comment section. Your support means the world to us. Until next time, keep creating and inventing, and I will see you in the next video.